So in this video, we're going to look at 4 different examples of using the binomial theorem. I advise you to pause the video before I do it, have a go at the question yourself, and then see if you get the answer right by watching my example. So in the first one, we're going to do 2x plus 1 over x to the power of 12. We've just got to write down the first 3 terms and the last 2 terms, and it says, do not simplify your answer. So let's do it then. So we're on the 12th line, so I'm just going to write down 12, 0. And let's write this in terms of a and b first of all. So let's say that a is 2x, okay, b is going to be 1 over x. So I'm going to have a to the 12 plus 12, 1, a to the 11b plus 12, 2, a to the 10, b squared plus, no, I only need those first 3 terms. The last 2 are going to be 12, 11, ab to the 11, and 12, 12, b to the 12. And I'm only getting these from the fact that I know that relationship as a is going down, b is going up. I've got 12 terms. That's all I need. So substituting in 2x for a and 1 over x for b, I'm going to be left with 12, 0, 2x to the power of 12 plus 12, 1, 2x to the 11 multiplied by 1 over x plus 12, 2, 2x to the 10, 1 over x squared plus 12, 11, 2x multiplied by 1 over x to the power of 11 plus 12, 12, 1 over x to the power of 12. And when they said do not simplify, that's how we're asked to leave our answer. We're not going to go and find those values at all. That is it. Okay, on to the next example. Now, this time we have to find the 7th term. We don't want anything else. We just want the 7th term. So if I'm thinking about this, okay, we are definitely on the 14th line of Pascal's triangle. Okay, the first thing I'm going to write down is I know the coefficient, all right, is going to be on the 14th line. So n is 14. And if we are starting from the left and moving across 7 terms, that means our R value is going to be 6. Now, it's not going to be 7 because we start from 0. So 0, 1, 2, 3, 4, 5, 6 is the 7th term. So there's our coefficient. Now, next thing we've got to worry about then is what are we going to have as our powers of A and B, right? Or I should say 3x and our minus 4 over x squared. Now, there is a generic term that we wrote down in the previous video for a typical binomial expansion, and we're going to use that now, right? So that typical term was nr a to the n minus r b to the r. That is a generic term, okay? And the good news for us is we already know that n is 14 and r is equal to 6. So all we've got to do is we've got to plug all these values in, and hopefully that is going to give us the correct answer. So a is 3x, right? So we're going to have 3x to the power of, well, we're going to have n is 14 and r is 6. So 3x to the power of 14 minus 6. And that is going to be multiplied by b, which is minus 4 over x squared, all to the power of r, which is 6. So there we go. Let's write this out just a little bit simpler than that. So we're going to have this as 14, 6 multiplied by 3x to the power of 8 multiplied by minus 4 over x squared to the power of 6. So this is going to be really important for us. We're going to need to remember that for lots of different examples in this video. Right, that's 2 done. Let's go and see some more challenging ones now, where we do need to use the calculator to find various coefficients. So in the expansion of x squared plus 4 over x all to the power of 12, we're going to find the coefficient, so what is in front of the x to the power of 6, and we're going to find the constant term. So straight into this, let's start writing some things down that we know. Perhaps because this is a more complex question, let's just go straight in and say that a is x squared, b is 4 over x, and n is going to be 12. All right, so remember that typical term that we know about. Let's write that out now, right? N minus r, b to the r. Okay, so that is where we're going to start. That's our typical term. Now, what can we say? Well, we know that we have to get somehow an x to the power of 6, right? We have to get an x to the power of 6. So let's start thinking about that, right? So, and I only want to just think about this bit now. The coefficient we can find out later on. Let's imagine putting in our a and our b and our n into this and thinking about what would it take and what would r have to be to get a power of 6. So a is x squared, so we're going to have x squared to the 12 minus r, because we know that n is 12, multiplying by, now, I'm not going to worry about the 4 too much, but we'll write it in just for completeness. I'm going to call 4 over x 4 to the x minus 1, and we've got that to the power of r, right? Now, we know that this is going to give us a x to the power of 6. There's going to be some number on the end because of that 4, right? But I'm not worried about it. I'm only going to consider the powers of x right now. And I'm doing that because we're targeting powers of x. Right, well, we can multiply these out using our laws of exponents. So if we do that, we can see that the value of the first x is going to be x to the power of 24 minus 2r, and multiplying by x to the power of minus r is going to be x to the power of 6. So that means that this, okay, is going to generate for us that 6. So 24 minus 3r, that's the 2r and the minus r combined, must be equal to 6. So if I take away 6 from both sides and I add 3r, I'm going to have that 18 is 3r, which means that my r value is 6. And now we're in good shape. That's what we needed to find. So going back to this generic term, right, we've got our r value now, which is 6. Let's write that down. R equals 6. We can now put everything in to get the answer we need. So nr is going to be 12, 6. We're going to have x squared to the power, well, 12 minus 6 to the power of 6. We don't need to worry too much about x's at the moment because we're only asked to find the coefficient. But we do need, we've also got that 4 to worry about. So we're going to have 4 over x to the power of 6 as well. So the coefficient part of this is the only thing that we're concerned about. And that's going to be 12, 6 times the power of 4, 4 to the power of 6, right? And that 4 to the power of 6 is coming from there, all right? So if we work that out, we can do it on a calculator using the combinations button, right? And that comes out at 3784704. Check you get the same answer as me. And there it is. That is going to be the coefficient of x to the power of 6. Now, let's think about part B to this question. So in this part, we're asked to find the constant term. Now, a constant term is one that doesn't have any variables in it, and a variable is the x. So we're looking to try to find a term in this expansion which has no x's in it. And as you can see from the question, we've got x's on a denominator, and we're trying to look for a place where they're going to cancel with the x's on the numerator. So our overall sort of power of x that we want to find is going to be like, imagine it as an x to the 0 term. Well, we can use our previous work to help us with this already, because back over here, we created, in fact, it's here, sorry, an expression that was sort of matched up with the power of x. So we originally wanted 6 because we're looking for the coefficient of x to the 6. Well, now we want that to be 0 because we're looking for the x to the 0 term. So 24 minus 3r is equal to 0. So that will mean that 24 is 3r. And that means that in this particular case, r is going to be 8. So if we know that r is 8, then our generic term is going to become 12, 8, x. Well, we don't need to worry about any x's. Let's not worry about that. All we're going to have to worry about, okay, is doing the 4 value up here 4 to the power of 8. That's all we need because we know already the x's are going to cancel. So if we work that out on our calculator, we should get 32440320. Okay, one final example. All right, okay. So let's finish this off. Okay, we've got another one of these where we've got two different brackets. Now, we've got to find the coefficient of x to the power of 5. Now, when we do this, we're again, like in the previous version of this question we did in another video, we're going to start by only considering the 2x minus 1, all to the power of 6. Now, if I was going to expand this, I'm going to get lots and lots of terms. Of course I am, right? But my leading term, my leading power of x, okay, is going to definitely have an x to the power of 6 in it. So I don't know what this is, but I know it's going to have some x to the 6 terms. It's going to have some x to the 5s, right? It's going to have some x to the 4s, x to the 3, x to the 2, x to the 1. Now, I also know that I'm going to end up multiplying all these terms by an x and by a plus 3, right? So I'm not even going to work them all out. I'm just going to start thinking about what's going to happen when I do this multiplication later. Now, I'm only looking for the x to the 5 terms, right? So if I had the x to the 4 term from the expansion and I multiplied it by x, I'm going to get here a term that does have an x to the 5 in it, all right? But as well as that, there's going to be another one, because when I times the x to the 5 term here by a constant, that's also going to generate an x to the 5 term. So I've got to be sneaky here. The only thing, this is a big question, but I can save myself a lot of time by only worrying about the 2 terms circled there, multiplying one of them by x and multiplying one of them by 3. That's going to build up a big picture and give us the answer that we're looking for. Okay, so let's do it then. So the x to the 5 term, well, that's going to be 6, 1, because we're the second across on the 6th line of Pascal's triangle. We're going to have 2x to the power of 5, and there's going to be just one lot of minus 1 there. And the other term, so that's the x to the 5 term. The other term we're going to need is 6, 2. We're going to have 2x to the power of 4 for this one. And we're going to have a minus 1 being squared, right? Now, I'm doing this a lot quicker than usual, but that 2x, look, that's my a. The minus 1 is my b. I'm putting them into the binomial theorem as I'm getting these. All right, so we're only interested in coefficients, but let's work this out. So, now, the x to the 5 term, we thought about that being multiplied by 3. And the x to the 4 term, we thought about that one being multiplied by x. So let's keep that in mind as we do these questions and work these out separately, and then we can just add them together. So if we do this, we are going to have, well, 6, 1 is 6, so we're going to have 3 times 6 times 32x to the 5 times minus 1. And if we do the other one, we're going to have, again, x to the 5 with the x and the x to the 4. 6, 2. I'm just going to write it as 6, 2. I haven't worked it out yet. Okay. It's going to stay there. We're going to have a 2 to the 4, which is a 16, and the minus 1 times minus 1 is just going to make a 1, so we can leave that. Right, so what's going to end up happening is our x to the 5 term will be a combination of those numbers and those numbers added together. Okay, so 3 times 6 is 18, so this is going to be like 18 times negative 32. And I'm just going to write 6, 2 there, multiplied by 16. Right, if we add those up, we're going to end up with a minus 336. Right, I hope you've understood that. That's a very tough question. I've done that in a time-saving way to try to make sure we remain efficient as possible in those exams. All right.